April 1940. Britain faced a coastal defence problem that traditional naval thinking couldn't solve. German E-boats were striking Channel convoys with impunity, disappearing into the darkness before destroyers could respond. The Kriegsmarine's fast attack craft were sinking merchant vessels within sight of English shores, and the Royal Navy possessed exactly the wrong tools to stop them. Destroyers cost £200,000 each, required 18 months to build, and were far too valuable to risk in shallow coastal waters hunting nimble raiders. The Admiralty needed something different, something fast, cheap and expendable, something that could be built in yacht yards rather than naval dockyards. The answer arrived wrapped in plywood and powered by aircraft engines, the Motor Torpedo Boat. These vessels cost roughly £30,000 each, 1/7 the price of a destroyer, and could be built in 6 months by furniture makers. They were constructed from mahogany and glue, carried crews of 12 instead of 200, and would never win awards for comfort or seaworthiness. They also achieved something remarkable. By war's end, British MTBs had destroyed millions of pounds worth of enemy shipping while losing only a fraction of that value themselves. This is the story of how Britain won the coastal war with plywood and petrol. The problem began with geography. The English Channel, barely 20 miles wide at its narrowest point, had become a shooting gallery. German forces controlled the French coast from Cherbourg to Calais, providing perfect bases for fast attack craft. Every night, Kriegsmarine S-boats, called E-boats by the British, raced across the Channel, torpedoed merchant vessels, and vanished before dawn. Destroyers were too slow to catch them, too expensive to deploy in shallow waters mined by both sides, and too large to navigate coastal areas where E-boats operated. The Admiralty needed vessels that matched E-boat capabilities: 40-knot speed, shallow draft, heavy armament, and most critically, numbers, lots of numbers. A destroyer might sink one E-boat if everything went perfectly, but E-boats operated in groups, attacking from multiple directions. What Britain required wasn't a better weapon. It was enough weapons to blanket the coastal approaches so thoroughly that E-boats couldn't avoid them. Commander Peter Ducarny, managing director of Vosper Lutid, had been developing fast patrol boats since the 1930s. His company built luxury motor yachts for wealthy clients, specializing in high-speed planing hulls that could exceed 40 knots. In 1936, Duquesne designed MTB 102 as a private venture, gambling that the Admiralty would eventually need exactly what he was building. The prototype cost Vosper £25,000, money the company couldn't necessarily afford, but Duquesne understood that war was coming and that Britain's coastal defence would require speed over size. MTB 102's hull was constructed from double-diagonal Honduras mahogany planking over Canadian rock elm frames. No steel, no armour, just wood, glue, and 43,000 copper rivets holding layers of plywood together. 3 Italian Isotta Fraschini engines generating 3,300 horsepower drove her to 48 knots light, 43 knots loaded. She measured 70 feet long, displaced 33 tons, and carried a crew of 12. 2 21-inch torpedo tubes provided offensive punch. She was essentially a racing yacht with weapons bolted on. The Admiralty tested MTB 102 in 1937 and immediately recognized its potential. But recognition didn't equal immediate orders. Naval traditionalists argued plywood boats were toys, unsuitable for serious military operations. The vessels couldn't survive heavy seas. They had no armor protection. Their wooden hulls would splinter under shell fire. Their petrol engines created massive fire hazards. All of these criticisms were absolutely correct, and none of them mattered. May 1940 changed everything. France collapsed, Germany occupied the Channel coast, and E-boats began their nightly raids. Suddenly, the Admiralty stopped debating whether MTBs were proper warships and started asking how quickly boatyards could deliver them. Orders flooded to Vosper, British Power Boat Company, and Thornycroft. Not just dozens, hundreds. The specifications were deliberately simple: 70 to 73 feet long, plywood construction, Packard marine engines, 2 torpedo tubes, machine guns. Any competent boatyard could build them. This proved transformative. Destroyer construction required specialized naval dockyards with heavy slipways, precision engineering workshops, and craftsmen trained to naval standards. Britain possessed 7 such facilities. MTB construction needed none of this. Vosper's main works sat in Portsmouth Harbour alongside yacht builders and furniture makers. When production accelerated, contracts went to companies that normally built pleasure craft: Camper and Nicholson, John Wise, Thornycroft, Whites of Cowes. These yards understood wooden hull construction intimately. They'd been building racing yachts, fishing vessels, and motor launches for decades. The material choices made mass production possible. Destroyers required specialized naval-grade steel, precision turbine components manufactured in dedicated foundries, and electrical systems built to military specifications. MTBs used commercial-grade mahogany from Honduras, rock elm from Canada, and plywood from ordinary timber mills. The engines were Packard 512s, originally designed for luxury automobiles, marinized for boat use. When Packard production couldn't meet demand, British yards installed whatever powerful engines they could source, including aircraft engines adapted for marine service. Construction speed reflected these compromises. At Vosper's Portsmouth works, an MTB hull took shape in open sheds using techniques yacht builders had perfected over decades. Craftsmen laid diagonal mahogany planking over bent elm frames, gluing and riveting each layer. The process was labor-intensive but didn't require specialized equipment. A team of 20 skilled woodworkers could complete a hull in 6 weeks. Engines, torpedoes, and guns were installed in another month. Total construction time, 8 to 10 weeks from keel laying to sea trials. Compare that to HMS Javelin, a J-class destroyer laid down at John Brown and Company in September 1937. Her construction required precision-matched turbine components manufactured in 3 separate factories, electrical systems custom-designed for naval specifications, fire control equipment built to tolerances measured in thousandths of an inch. She commissioned in June 1939, 21 months later, representing 400,000 man-hours of highly skilled labor. Javelin was undeniably superior in every category. She displaced 1,700 tons versus an MTB's 33 tons. Her 6 4.7-inch guns vastly outgunned an MTB's single machine gun armament. Her steam turbines generated 40,000 horsepower compared to an MTB's 3,300. She could operate in any weather, cross oceans, fight surface battles. She was also one ship. In the 21 months required to build Javelin, British yards completed 90 MTBs using the same labor hours distributed across woodworkers, not naval architects. The cost differential was staggering. A destroyer consumed £200,000 in 1940 currency, roughly £10 million today. An MTB cost approximately £30,000, about 1.5 million modern equivalent. That 7-to-1 cost ratio meant fundamental arithmetic changed. For the price of 1 destroyer, Britain could deploy 7 MTBs. For the construction capacity required to build 3 destroyers, boatyards could launch 40 MTBs. The cheap plywood boats weren't replacing destroyers. They were filling a role destroyers couldn't perform economically. But cost-effectiveness meant nothing if the vessels couldn't fight. MTBs had to prove themselves operationally, and the first tests came quickly. June 1940, MTB 102 participated in Operation Dynamo, evacuating troops from Dunkirk. She crossed the Channel 8 times, carrying soldiers under fire, serving as flagship for Rear Admiral Wakewalker when his destroyer, HMS Keith, was sunk. The plywood boat that traditionalists had dismissed as a toy was performing missions under conditions that would test any vessel. The tactical doctrine developed rapidly. MTBs operated in flotillas of 6 to 8 boats, hunting at night when their low profiles made them nearly invisible. They ran on silent auxiliary engines when stalking targets, then unleashed full power 40-plus knots for torpedo attacks before enemy gunners could respond. The tactics were simple: approach undetected, fire torpedoes at point-blank range, 300 to 500 yards, then disappear at maximum speed behind smoke screens. No standing and fighting, no heroic surface battles. Hit hard, run fast, survive to attack tomorrow. The weapons made these tactics viable. 21-inch torpedoes carried 750-pound warheads capable of breaking a merchant vessel's back. MTBs typically carried 2 torpedoes, though later variants mounted 4. The boats also carried depth charges, Oerlikon 20mm cannon, and multiple machine guns, evolving from pure torpedo boats into versatile gunboats capable of engaging E-boats, defending against aircraft, and supporting commando operations. The human element proved equally important. MTB crews were volunteers, typically young officers barely out of training and ratings who preferred action over routine. They operated in conditions that would have destroyed morale on larger vessels. The boats rolled violently in any sea state above flat, calm wooden hulls, amplified every wave impact. Crews stood watches on open bridges, exposed to channel weather. Petrol fumes permeated living spaces. High-octane fuel, 5,200 gallons in some variants, surrounded the crew, turning every engagement into potential catastrophe if shells penetrated fuel tanks. Yet these boats performed. MTB flotillas based at Dover, Felixstowe, and Portsmouth hunted nightly. They intercepted E-boat formations before they reached convoys. They attacked German coastal convoys, moving supplies along the French and Belgian coasts. They laid mines in enemy harbors. They supported commando raids, delivering troops to beaches and extracting them under fire. The operations were dangerous, casualty rates high, but the mathematics favored Britain. When MTB 238 was sunk by E-boat gunfire in October 1942, Britain lost £30,000 and a crew of 12. 7 weeks later, Vosper launched MTB 380 to replace her. The entire cycle, loss, replacement, commissioning, took less time than building a single destroyer. This economic resilience mattered enormously in attritional warfare. Between 1940 and 1945, coastal forces lost approximately 200 MTBs and motor gunboats to enemy action, accidents, and weather. Replacing them cost roughly £6 million total. Replacing 200 destroyers would have consumed £40 million and monopolised British shipyards for decades. The strategic impact became clear in the Channel War statistics. By mid-1943, Britain operated over 300 MTBs and MGBs in coastal forces. This numerical superiority transformed coastal defence from desperate scrambling to systematic coverage. No convoy sailed without fast-boat escorts. Every E-boat sortie encountered British MTBs. German coastal traffic faced constant harassment. The E-boats that had terrorized Channel shipping in 1940 to 1941 found themselves hunted by flotillas they couldn't avoid through superior numbers. The tonnage destroyed by MTBs accumulated steadily. A German merchant vessel sunk off the Dutch coast, 3,000 tons. An ammunition ship torpedoed in the Channel, 4,500 tons. Supply barges destroyed during cross-channel raids, 200 tons each, but dozens of them. The individual actions weren't spectacular. No MTB ever sank a battleship, but the cumulative effect was strategically significant. By 1944, German coastal convoys required destroyer escorts to defend against MTB attacks. Destroyers pulled from more important duties because Plywood boats had made coastal waters too dangerous. The D-Day operations showcased MTB versatility. In the weeks before June the 6th, 1944, MTB flotillas maintained continuous patrols, preventing German E-boats from discovering the massive invasion fleet assembling in southern England. During the invasion, MTBs screened the flanks, attacked German reinforcement convoys, and defended the beachhead from E-boat counterattacks. They performed missions ranging from torpedo attacks to minesweeping to rescue operations, whatever coastal forces required. The final accounting tells the story. British yards built approximately 400 MTBs during the war, from the early 60-foot boats to the later 73-foot Vosper designs. Canadian yards built another 100-plus under license. Production cost roughly £12 million total, about 6% of what an equivalent destroyer force would have cost. Those vessels participated in actions that destroyed hundreds of enemy vessels, totaling millions of tons of shipping, tied down German coastal defenses, and enabled amphibious operations that would have been impossible without fast boat superiority. The destroyer HMS Javelin, that magnificent 200,000-pound warship, was torpedoed and severely damaged in November 1940, repaired at enormous cost, torpedoed again in 1942, and spent the rest of the war in reduced operational status. She'd cost more than 6 MTBs, required years to repair when damaged, and performed missions that, while important, couldn't include the shallow water coastal operations where MTBs excelled. This wasn't a story of replacing quality with quantity. It was recognizing that different missions required different tools. The Royal Navy needed destroyers for ocean escort, surface combat, and fleet operations. But it also needed fast, expendable coastal craft that could be risked in shallow waters, built quickly when lost, and deployed in numbers that created tactical superiority. The 30,000-pound Plywood boat filled a niche the 200,000-pound steel destroyer never could. The human cost was real. Approximately 1,400 officers and ratings of coastal forces died during the war, a casualty rate reflecting the dangerous nature of fast boat operations. But those losses occurred while preventing far greater destruction. Every E-boat sunk before reaching a convoy was dozens of merchant vessels saved. Every German supply ship torpedoed was ammunition and fuel denied to Wehrmacht units. Every successful MTB patrol was a calculation in Britain's favour. After the war, most MTBs were scrapped or sold off. A few became houseboats, their hulls stripped of engines and weapons, ending their days moored peacefully in marinas. MTB 102, the prototype that started it all, survived and has been restored as a museum piece. A reminder of when furniture makers built warships and yacht racing technology became a weapon of war. The lesson wasn't that plywood was better than steel or that cheap was superior to expensive. The lesson was that wars are won by matching resources to requirements. Britain couldn't afford to build hundreds of destroyers, couldn't risk them in coastal shallows, and couldn't replace them quickly when lost. But Britain could build hundreds of MTBs, could risk them in any water, and could replace losses within weeks. The strategic calculation was brutally simple. Adequate weapons available immediately beat perfect weapons arriving too late. By choosing plywood over steel, speed over armor, and quantity over individual capability, Britain gained control of coastal waters that traditional naval thinking would have surrendered. The 30,000-pound MTB couldn't match a 200,000-pound destroyer in any single capability. It didn't need to. It just needed to be fast enough, cheap enough, and numerous enough that E-boats couldn't avoid them and German coastal convoys couldn't escape them. In that mission, the humble Plywood boat succeeded brilliantly. The Motor Torpedo Boat program cost £12 million and saved Britain's coastal approaches. A destroyer-based coastal defence strategy would have cost £60 million and been impossible to implement. That £48 million difference funded other operations entirely, operations that won the war. Sometimes the best weapon isn't the most powerful or the most sophisticated. Sometimes the best weapon is simply the one you can afford to build in the numbers needed when you need them.